So you've already seen a function already so far in the class, and the one you've been probably using the most is the main function, int main, which is essentially the building block of C++ programming. However, int main is not considered a user-defined function where you define it if you wish to. It's considered a main function that is required by C++. If you don't have a main function and it has to be called main, M-A-I-N, then your code will not run. So that function is not user-defined. However, for the topic of this of today, the functions we are going to be discussing are the ones you can define yourself, functions besides main. And we've already seen some of those functions in past lectures. For example, when I covered arrays, we've seen a function like dot size function for vectors. You also have like dot pushback functions. So these are built-in functions in certain libraries that you include in your program if you wish to use that certain data structure. So functions can be user-defined. You can customize your own functions. It's really up to you. And if you want to think about it, functions are, if you remember in algebra, they're basically kind of like f of x equals to something like x plus y, whatever the statement of the function is. So similarly, functions in programming behave the same way, where within the parentheses you pass in what's called parameters, which we will get to, and these parameters act as the data to the function, and then the function at some point will return something, just like in mathematics, where you pass in an x as an argument to the function. You expect a return result at the end from that function. Similarly, that's how functions behave in programming. Okay. So C++ provides some predefined functions, as I mentioned, like main, which is used to execute code, but you can also create your own functions. And in order to declare a function, this is a syntax that you use, at least in C++. For the most part, this syntax is shared across many languages, especially those that are object-oriented, like Java, if you've taken a Java programming class. You also have like C#, .NET language, and other languages that behave similarly in the same syntax. Okay, so the syntax is generally where you give it a data type, just like you do for a variable. So we've covered the different data types like int, float, double, and so forth. So similarly, as you do for a variable, you give the data type first, and then you give the function name, whatever you want the name to be. So in this case, it could be like void as a data type. Now void means that the function does not have a return value. Depending on the situation, you might find the void helpful if you don't want to return anything in your function. Otherwise, you might find it unnecessary and you might use a different data type. Okay. So just like variables, you pass int as a data type, or you define that int as a data type for the variable. If you are trying to use whole numbers, you use float as a data type. If you want to use in decimals of 4 bytes, you use double for a variable. If you want to pass in decimals of 8 bytes, so double the length. You use char for a data type if you want your variable to carry only characters. The same exact thing is declared for the function. Okay, so the only difference is that this is a function and that is a variable, and the function allows you to do a certain thing, return different results, while the variable is just given, whatever you assign a value to be, it will always be that. Okay. So to call a function inside the main, all you do, and this is known as function prototyping. You might find that term used across other languages. So to call a function, all you do is, once you have it defined in your main function, you just pass the name of the function, and that's how you call it. Okay. So for example, in this case, let's say we created void my function, and in this example, all this function does is that it prints out I just got executed, right? So in your main function, what happens is you call my function, and this cout will get executed at that point. Now, do not think that because you have the my function right there, it will get executed if you don't call it in the main. If you don't call it in the main, then nothing will happen. Your code will not recognize this function because the main is the main portion of C++. So you must call the function, otherwise it will not do anything, okay? So you can actually call a function multiple times. It's not going to give you an error. So again, with the same previous example, if your function is only outputting something like I just get executed, and you call it 3 times like this way in the main, then it will print the same thing over and over 3 times, however many times you call it, okay? So in C++, a function consists of 2 parts: the declaration, the function's name, the return type, and the parameters, if you have any parameters, okay? You might not want to include parameters, or for the most part, or oftentimes, you do include parameters, or they're also known as arguments, okay? And what that means is you pass them between these opening parentheses and closing parentheses. And that would be the declaration of the function. Now in this case, if we're using void, remember void kind of acts like there's nothing to return. Okay, it's basically void. It's an obsolete function. But if you are using an int data type, so let's say this was called int my function, then you must return something. Typically, if you're using an int my function, it could be maybe to use it for addition purposes, subtraction, performing some sort of calculation within that function. But let's say you're returning something like, just a simple cout, then there is no point to really return like an addition or summation or whatever you call it, okay? So really, depending on the scenario you're in, you can use functions and data types in whatever way you want them to be used, okay? So then we get to the definition, the body of the function. So this is where inside the function, between these opening and closing curly braces, you build the code inside this function. So all this time you have been writing your code inside int main for the past 2 assignments, right? You might find it helpful, instead of writing all this code inside the main function, you can create a function that does exactly the same solution. Like you can call it void solution, and then all you have to do is just call the solution inside the main. So that if someone is looking at your program and the very first thing they look at is the main function, they notice, oh, there's a solution function that I'm pretty sure it's doing something to solve the program given to me. So, it's cool to look at the main function and not find so many blocks of code in there. And it makes it look organized and more simple to the onlooker. Okay. Any questions so far? I will be showing an example, several examples actually, but for now I'm just explaining the syntax so that when I show the example, you're familiar with what's happening. Okay, so if a user defined function, such as the one given in the previous examples, my function is declared after the main function, an error will occur. Okay, this is because C++ works from top to bottom. So for example, in the previous examples here, you notice that we defined my function on top of int main, right? Now, it kind of makes sense that, of course, you have to define it before the int main so you can call it, right? There are other programming languages that allow you to define functions under the main, okay, and main still recognizes them. But in C++, that's not the case, okay? So that is a slight difference between other programming languages and C++. But generally speaking, a lot of people just define the functions on top of the main. There is a way where if you want the person looking at your code to just see the main as the very first thing, you can place your functions at the bottom and then still make main recognize them by passing only a simple line at the top. And I will show you an example for that when we get to it, okay? But again, all the slide is saying here is that make sure that if you define your function at the bottom, that it's also defined somewhat at the top, and I'll show you how to do that. Otherwise, always make sure you have your function before the main, okay? So it is possible to separate the declaration and the definition of a function for code optimization. So this is exactly what I was talking about in the previous slide. If you want to define your functions after the main, just so that the main can be the very top thing in your program, then all you have to do is just pass the data type at the top of the main, and the name of your function exactly as it is. And if you have any arguments, you pass them the same way as it is. So the only difference really is that, notice here at the bottom, like we have the opening curly braces and the closing curly braces, and we have something inside there. But at the top, all we have is just the data type of the function name, and then opening parentheses and closing parentheses, and then we end it with a semicolon. So this will work, okay? And the reason for that is because now main recognizes, oh, there is a function called my function, and I can recognize it because, you know, it's coming before me. I don't really necessarily need the code within this function to be on the top, because I can reference it at the bottom right here. Okay, as long as I have it somewhere here, then I'm good. Okay, and that's how the main function generally acts. Okay, now before we get to an actual example, there is one more topic I'd like to cover, which is parameters and arguments. So as you might know, information can be passed to functions as parameters. These parameters act like variables inside the function. You've already used variables over the past couple assignments, and you've seen how, you know, you can use variables in different scenarios. The only thing here is that instead of defining your variables like int x equals 2 or something like that, or int y or int variable, or float, whatever, you just do the same thing, but within the parentheses of the function here. Okay, so parameter 1 could be called int x, parameter 2 could be called int y, parameter 3 could be called int z, something like that. Okay, and you can have different data types as well for the different parameters. Okay, so it doesn't have to be int, int, int. You can have like double here, like double x, float y, and char z, something like that. Okay, so depending on the use case you're given, you can make your function parameters diverse as you wish them to be. Okay, and you can add so many parameters. It's pretty much, you know, up to you. You can add so many different parameters. You can add 5 parameters. You can add 10 parameters. Okay, so in this example, we have a function that takes a string data type, and the string variable is called fname. Okay, like first name. When the function is called, we pass along the first name, which is used inside the function to print the full name. Okay, so instead of printing out all the time, you know, see out Jenny or something like that, and the function will only print Jenny anytime you call in the main, you can make it dynamic where you can, you know, pass whatever value to the function, and it will print it. It will act on it within whatever is inside that function. Okay, so in this case, inside the main function, we are calling my function, and we are passing different values to replace a parameter. So just like in mathematics, where in f of x, you replace x with a number or several numbers, the same thing in programming. Okay, you call the function, so let's say my function f, and then of, and then x in this case could be, you know, the string name, which is the first name. Okay. You can also use a default parameter value by using the equal sign. So if we call a function without an argument, it uses the default value Norway. Okay, so in this example here, because we're not necessarily making a variable constant, or let's say that if the user does not pass in any value to the function, like in this case, then your function has to still print something, right? So if you don't pass a different value, you can set it to a default value like this way. Okay, so just like defining variables inside the main function, you can give the variable a value, and you can change it later as you wish. Okay, so in this example, we have my function, and we gave it Sweden, so it overrode Norway. Okay, so it changed the value of Norway. Now, this is actually a good point for me to explain or introduce a concept known as pass by value and pass by reference. So we'll see pass by reference in the next few slides, and we'll actually see pass by reference in the next week's lecture about references and pointers. But there is a general idea in C++ known as pass by value and pass by reference. For the most part, if you do decide to use functions, you'll most likely only be using pass by value. Now, of course, you're probably not going to know that you're using pass by value, but by default, you are technically using pass by value technique. In this case, this is pass by value. You can recognize it that way because it does not have an ampersand sign. When we get to pass by reference, you'll see the difference is that we are going to have an ampersand sign, and this is how you know it's pass by reference. Okay, but anyways, focusing on the slide here, if we have my function and we pass in Sweden, it overrode the country default value, which is Norway, and it's going to print Sweden instead. Same thing for India, but in this third line right here, my function, we didn't pass any value to it, so the default is going to be whatever you pass in the parameter, which is Norway. Okay, as I had mentioned earlier, you can also pass several parameters. It doesn't have to be only one parameter in your function. So depending on the use case, you can pass in however many parameters you want. Okay, so in this case, again, my function, we have the first name, but let's say we also want to pass the age about that person. So you can say, pass the value into the function in the main, and then comma, and then give it the second value, which is whatever the second parameter is about. So in this case, we have string f name. So the first parameter will always have to be a string. If, let's say you give 3 right here and then comma Liam, then what will happen is you will get an error because the sequence of parameters in this case have to be a string first and then an integer second. Okay, so always be careful of the way you pass values. They have to match exactly the same. Okay, string here, the first parameter. Int as a second parameter, so we pass an integer as a second parameter. Okay. So I mentioned that in the previous examples, they're using void, which means we don't have to return anything. But if you notice for the main function, we have int main, we are always returning 0. Okay, we are always telling the code return 0 when the program actually runs, right? And this is required because main is not a void main, it's an integer function. You can actually kind of play around with it and change the int main to void main. So this way you don't have to return anything. Actually, you can't return anything if you have void. But generally speaking, most of the time you've just been using int main as is, right? Okay, so if you do decide not to use void for your functions because let's say you have to return something, so especially if you're using an integer data type for the function, such as int my function, you want to return some sort of thing to the user, right? You need to return something. So in this case, you can return the addition of whatever parameter you pass plus something. Okay. So over here, if we pass in 3 and it says here return 5 plus, then we're going to replace x with 3. That's going to give us 8, right? If we pass in 4, 5 plus 4, it's going to give us 9. Okay. So make sure, depending on the data type, if you're using int, string, double, whatever, you must return something. If you're using void, you can't return anything. Okay, that is the difference between void and the other data types. Okay, so in this example here, we return the sum of a function with 2 parameters. So we have my function, instead of defining here, instead of hard coding 5, we're allowing the user to enter the 2 numbers actually. Okay, so we replaced 5 with y. So now we can allow the user to enter the 2 dynamic values without having the values hard coded in the code of the program. Okay, you can also store the result in a variable. So you can actually assign the return of the function to a variable. In your previous programs, you probably would say int z equals 0 or int z equals 1, something like that, or int x equals 3 or whatever. You can do pretty much the same thing for functions. You can assign it the value of whatever is returned from the function. Okay, so all you have to do is just define the variable and then the assignment operator, which is equals, and then the same as you've been doing here, except you're just putting the function instead. Okay, and then this way you can see our z. So this will output the same thing that this example here outputs. Okay, so before we get to pass by reference, let me show some example. Okay, let's say that we are told to write a function which returns, okay, so keyword here returns. So that means we don't want to use void, we want to use other than void. So something like integer, right? Or string, depending on what we are given. Okay, that returns max number. Okay, so we are being told that we want to return a max number. So we can immediately say it's either going to be integer, float, or double, either one of the numerical data types. Okay, max number of the 4 first arguments. So we are told that this function is going to have 4 arguments, 4 parameters that it's going to receive. Okay, so let's suppose the input looks like this. Okay, and the output in this case will be, what is the max of these 4 numbers here? It's 6. Okay, so the expected output is going to be 6 because 6 is greater than any of those given 4 numbers here. Okay, so let's begin. Okay, so we are told we are going to have 4 parameters, and for that we are going to define int a, b, c, and d. Okay, so we have 4 different integer parameters. Okay, so next, instead of performing the calculation inside the main, we want to perform it within a different function, and then we just want to call the function inside the main. And the way we do that is, let's suppose we call function, we can call it like max of numbers, and a, and b, and c, and t. Okay. Now we don't end the last parameter with a semicolon. This will give you an error. Okay, so you only end semicolons within a block of code. Anything within this parentheses here, you don't end it with a semicolon. Okay, so you just leave it at that. So now we open the curly braces and the closing. Okay, so if we are given the 4 parameters here, which by the way don't have to be called A, B, C, D, we can actually call them like X, Y, okay, Z, something like that. And you can have the different parameters here because it doesn't matter what the variables are called here, since you're just going to pass the values, right? Pass by value. So you can have them called the same, okay? Or if you have it int A here, this int A right here is not the same as int A right here, okay? This is different because whatever is inside the main function is outside the scope of this function right here that you're defining, okay? So you can call them whatever you want, or you can, if you want to keep the same, like the same organization across your code, so you can recognize the variables faster, you can also name them the same way, okay? So because we have now the 4 parameters given to us, we are returning the max of the 4 numbers. So in C++, we have a nice function to use for that. It's called max. Okay, so all they have to do is just return, and then instead of returning 0 like we do in the main, we are just going to return what we are told to return, which is the max. And in this case, we can do it max of A and B, and we can say another max of C and D. Okay, now what does this mean right here? Okay, so we are saying first, remember in arithmetic we have order of operations. You can think about what we're doing here the same way. Okay, so first we begin from inside, all right? So we are saying we want to take the max of parameter A and B. So let's say we are given 2 and 3, okay? Or actually, let's use a sample input here. let's say we're given 3 for A and 4 for B, right? So what is the max of that? It's going to be 4. 4 is greater than 3, so that's the max of the first expression here. Now, the second expression says, what is the max of C and D? Okay, so 6 and 5. So 6 is greater than 5, so the max of that is going to be 6. So now, what this evaluates to, it evaluates to something like this. Return max of, okay, so we said that the first max, this one here, is going to be 4. And the second max of these two numbers here is going to be 6. Now, finally, we take the outside max, okay? So the max of 4 and 6, which is going to be 6. So this return is going to end up changing to return 6, okay? So this is one way to return the max. The other way you could do it is you could do something like this. Okay, so we can leave A. We can then say, give me the max of B, okay, and give me within the expression the max of C and D, okay? So what this is saying is, first, give me the max of C and D, which is going to be 6, and then now give me the max of B and whatever, you know, whatever one was the max of from C and D. So it's going to be between 4 and 6, and now give me the max of that, which is going to be 6. Okay, and then finally, we're going to have the max of 3 and whatever the max of all these 3 parameters were, which was 6. Okay, so then when we evaluate the entire thing, we get the max of 3 and 6. It's going to be 6. So you can do this in different ways, you know, as I have just showed you right now. But you might recognize that this might be a little more complex looking than the previous one. So let's just revert to the old one. Okay, so now that we have a function to take the max of the numbers, all right, all we have to do is just call it inside the main. And remember to call it, or this is called this function prototyping. All you do is just take the name of the function, okay? You can actually take it with the parentheses. And then whatever the values of A, B, C, and D, you just pass them in here as A. Okay, so whenever you call a function inside the main, you remove the data types essentially, okay? Because all you're doing is just replacing it with the values, okay? If this was a string, if these were a string right here, okay, then you just simply pass them as strings, okay? Of course, assuming that the data type here is also string. Okay, so we can actually hard-code the values at this point by, but why not make the program a little more dynamic than that? So let's tell the user to actually input the values. So cin A, cin B, okay? And you can actually chain the cin. So instead of saying cin separate lines, you can actually do it this way, okay? So we can just have a one-liner of code. cin A, B, C, and D, okay? Let's see. Oh yes, forgot to remove this. So this error is complaining about string. Okay, so this is one of the things I mentioned here. Make sure that you have your data types coordinated across the function as well as your definitions. Otherwise, you'll get an error like this. Okay, so I had to change the string back to integer. All right, so at this point, it's expecting something. Actually, let's give it a cout statement. for numbers by space. Okay, so first we have 3. Actually, let's take the sample input. So 3, 4, 6, and we can enter the last one on a new line if we want to. Okay. We passed all the values inside the function, but nothing is returned. And the reason for that is because we don't actually have an output. Nothing is being displayed on the screen. So what we do in this case, we can, if you recall, we said we can assign a function to a variable. So we can assign it this way. Int, let's suppose the variable is called max number equals to, and instead of prototyping the function here, let's assign it to the variable here. And then now let's see out the variable. Okay, so let's enter 3, 4, 6, and 5. And there we go, we get 6, which is exactly what we're expecting. I did mention that there is another way you could place the function under the main. If, let's say, your function is so long and you want the user to look at the main the very first thing in your program, so we can actually take this, cut it, paste it here. Okay, now we will get an error at this point. Okay. Okay, max of numbers function was not declared in the scope. This is the type of error you get if you have your function after the main. So if you want to do it, all you have to say, just take this and then paste it on the top. That's all you need to do. And there you go. Okay. So this is one neat way you could prototype your functions. You can have all your functions defined after the main and then just call them, have them over the main in just a one line like this. Or you can just essentially have your function defined before the main. It just makes it that you have to scroll all the way down to get to the main function if you have so many functions defined. Okay, so it's really up to you. You know, best design practices, whatever you want to do. There's generally a multitude of ways you can accomplish something. Any questions? Okay. We get to the topic known as pass by reference, which I briefly mentioned before, and this will come next week as well in the reference and pointers topics. But generally speaking, pass by reference allows you to change the variables, okay? Technically, you might run across a situation where you need to, let's say, swap numbers. If you don't have a pass by reference, like in this case, and you can tell it's pass by reference because if you have the ampersands before the variable, so these are the ampersand symbols. If you have that, it means this is a pass by reference function. Okay, so if you have that, then that means you're trying to change the value of the variable. Okay. So let's say we are told we want to swap two different arguments and output the swapping of this two arguments. Okay. So void swap, okay, numbers. So I'm giving the function name swap numbers, and because we are trying to swap two different numbers, we have int, and then x, int, and y. And this example is the same one that I have here. Int z. Okay, so what we're doing here is we're just switching the values between the two variables. Okay, so this is basically the operation of swapping. So in the main function, we are gonna define the first number, let's say first num equals to 10. Okay, so let's say that's the first number given to us as a parameter, and then the second number wants to, let's say 20. Okay. At this point, let's say before we pass the swapping function, okay, so before swap function, we are going to output the first number. So let's say first number and we're going to output the second number. What I'm doing here is basically just outputting the two variables just so I can show you what happens before swapping, which is going to be whatever is given to us, and what happens after we swap the two parameters. So at this point, we call the function, which will change the values of first num, second num. Okay, and to call the function, remember all you do is just take this, the name of the function, and replace what's inside it. And over here, you just pass in your integers. So our integers are first num and second num. Okay, so all this function is doing here is just swapping the values. It's not going to output anything, okay? Because again, remember, this is a void function. Okay, so at this point of time, I want to say what happens after we swap them. After the swap function, the first number becomes the first num, and the second number becomes the second num. Pretty much essentially the same thing, except now the two numbers are swapped. Okay. Let's see what it gave us. So before the swap function, the first number is 10, which is what we have. First number equals to 10. And then the second number is 20. Okay. So now after we called the function, we swapped the two different numbers. So now the first number is 20 and the second number is 10. Okay. This is what that function did for us. And this is essentially a way you can use pass by reference. Now let's say you did not have the ampersand here. Okay. Your program will not result in an error, but what will happen is it will not actually swap anything. That's because you did not actually change the value of the arguments. Okay, it was as if you just passed the value statically. Okay, it was passed by value. So if we run this, you're just going to get the same thing again. First number is 10 before swapping. second number is 20. After swapping, it's still 10 for the first number, and the second number is still 20. So what function overloading essentially does is you can have multiple functions with the same exact name, but different parameters and different operation on these parameters, okay? So how might this be helpful? There are really rare scenarios, as I mentioned, but one way you can think about it is, let's say you're trying to do perform an addition operation, okay? And oftentimes, I mean, if you take a look at your calculator can add whole numbers as is. They can add, 2 numbers, or you can add 5 numbers. You can add a number that's decimal. You can add the number that's not decimal, and you might be expecting a decimal result. But at the same time, like all these different operations, they're all essentially just an addition function, right? So instead of saying int addition 1, int addition 2, int addition 3 as your function names, you can have addition as your function name, so the same name across different functions, except it performs differently. And this is what's known as function overloading. You're just overloading the way the function is behaving, okay? Now, there are some rules when it comes to function overloading, but let's first consider the following example, okay? So we have 2 functions that add numbers of different types. So we have an int function, so we are expecting a return value, and let's call it plus function integer. So it adds the 2 parameters given to us, x and y. So let's say we are given 5 and 3. It's going to give us, an 8 as the value, okay? Now the second function, plus func double, okay? But essentially is doing the same thing, right? It's performing the addition operation on the 2 numbers given, except it's going to return some sort of double value, okay? So why would you have this? Why would you have 2 different function names and go through that trouble, especially if you have to do this like over 10 times for different data types and different operations, when you can have the same name and just let C++ figure it out for you. Whatever the user passes as their values, then the right function kicks in, okay? So what they're doing here is they're renaming the double function, this one, plus func double, as well as plus func int, okay? They are renaming them to a generic name like plus function, okay? And what these functions are gonna do, they're pretty much doing the same thing, x plus y. So all that happened for function overloading is we just rename the functions the same way, okay? So now if the user passes in the main, let's say they pass in 5.2 and 3.1, then your main function will automatically know that I want to use the second plus function. I don't want to use the integer plus function, okay? And this is kind of the benefit for function overloading, is that your program automatically knows what function you want to use depending on whatever the user enters as their inputs, okay? So in this case, we have a variable called my_number_1 equals to plus function 8 and 5, okay? And then double my_num_2 plus function 4.3, 6.26. So C++ automatically knows that, okay, for the first function here, I'm only getting an integer and an integer as values, as parameters, so 8 and 5. So that means I want to use the first function, okay? Well, for the second line here, my_number_2, I have double values or decimal values, 4.3 and 6.26. So C++ knows that it's gonna need to use this double function instead. So this is kind of the advantage for function overloading, all right? Let me show an example. So first, just some quick notes. Function overloading is a compile time. Polymorphism. Don't worry about polymorphism now. This is a concept we'll be covering when we get to object-oriented programming, which is in a few lectures. Essentially, if you want to know, polymorphism just stands for changing the shape, okay? So you might have come across this word before. For something to polymorph means for something to change its shape. So function overloading is an example of a polymorphism technique. Okay, so the easiest way remember function overloading. Okay, so in function overloading, these are essentially the 3 rules you need to abide by if you do decide to use function overloading. Your function or your functions should have different types. They should have different numbers, and they should have a different sequence of parameters. Okay, so something like this is acceptable. Let's say we have a sum function. Okay, that just adds 2 integers, so int num1, int num2. Okay, so that, let's say that's a regular function. If you want to overload that with different number of parameters, then it must have more than 2. Okay, so you cannot have another function defined the same exact way like this. You need to have a different, more than 2 parameters. So you will have to have something like int num3, or so again, you don't have to conform to all these rules. As long as you conform to one of them, your program will not result in an error. Okay, so the other acceptable variation is something like sum int num1. And let's say we only want to take 2 parameters. So in this case, according to this rule here, we need to have different types of parameters. Okay, so we can have double num2. Okay, so this differentiates it from the first version right here, different types. Okay, or so let's say you want to have another function like this, okay, that has integer and double. Then what you will have to do is you need to make sure the sequence of parameters is different. Okay, so like this. So we had integer first here and double as the second data type. Then you just make double as the first data type in the other overloading, and then integer as the second data type. Okay, so these are the different variations you can essentially have. Again, this is pretty much a very simple example. Depending on your scenario, just make sure you are conforming to at least one of the rules when you're using function overloading. Okay, let's see. So the first function I'm going to define is int sum, pretty much this function here. Okay, so because it's an integer data type, we are going to return something, and that is going to be the addition or the summation of the 2 numbers, so num1 plus num2. Okay, so num1 plus num2. So that is the first function given to us. Okay, if we want to overload that, we can have int sum, again, the same name, same function name, except this time we have to make it different. So we can make the sequence different. So we can have different sequence. Okay, and our return can remain the same. It doesn't have to be different as long as we are confirming somehow to the roles. Okay. Another one we can have is a different number of parameters, so more than 2 parameters. Okay. I'm going to shorten parameters to params. There's also another way you might see people using it as args for arguments. That's one way to abbreviate these long words. Okay. For example, 3 instead of 2. Okay. So instead of having just 2 parameters, we can have 3 parameters under the same function name. So I'm just going to copy this. And simply add. Okay. So because now we have 3 parameters, we just add onto the summation. Okay. And finally, for the last rule, different types of params. So in this case, we can just copy this. And since we might want to return a decimal value instead of a whole number, we can define this with a double data type. And we can change some of these types around because we have to. This will result in an error because you cannot have int, 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 and int, int, int for the same function name. Okay, so you must replace them. Let's say like double num1, double num2. And essentially, you can keep the last one as long as you have some sort of different types of parameters, which we do in this case. So it's somewhat different. As long as you have that difference between the 2 different functions, then your program will accept it. Okay, so now let's test it out. So we have cout. So first, let's test out the regular function. So that would be int. Okay. So sum of 10. Maybe like 20 and 15. Okay. So because we are passing 2 integers, 2 whole numbers, which of these functions here is going to get kicked off? The first one. Okay. That one suits our criteria, int and int. So that is the function that's going to be called. Okay. The second scenario is we want to test the difference sequence. Okay, so int and double. Okay, so which function over here we have int and double? This one right here. Okay, so your program, if you pass in let's say 20, but the second one is going to be a double, like 15.7, okay, then C++ is going to ignore this function and it's going to override it with this function because this one has a double, so it recognizes it. Okay. For the third scenario, we want to have different sequence once again, double and int. Okay, so what that means is we have double first. So let's say 30.5. And the second parameter is an integer, so it's going to be a whole number, let's say like 15. Okay, so what this means is C++ is going to ignore this first one because it doesn't match the criteria of a double first and an integer second. This one is not double first and integer second. Oh, this one is double first and integer second. Okay, so this is the function that C++ is going to call. Okay, the fourth scenario, different number of parameters. Okay, so instead of just 2 parameters, we want 3 parameters. So int, int, int. Okay, so C++ is going to look. This one only has 2, takes 2 parameters, 2 parameters, 2 parameters. Oh, we have this one that takes 3 parameters, and it's integer parameters. So that's the function we are going to call. Okay. So let's say like 81, 110. Okay. So C++ is going to know that this one fits the scenario of int, 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 which is this one right here. Okay. Finally, different type params. Okay. Double, double, and let's say double as well. Okay. Now we don't really have one that fits that scenario. What we have is double, double, and int. So for the third parameter, let's just pass an integer. Let's say 100.2, so that's our second double, and that's an integer, so we leave it. Okay, let's run the program. There we go. Okay. So 35, 20 plus 15, 35. For the second function, we have sum of 20 plus 15.7. We still get 35. Why is that? Because it called this function right here, which is an integer data type. An integer will not return a decimal value. So what happened is it rounded down and it gave us the same result, 35. Okay. For the third scenario, we have 30 and a half and 15. Okay, so 30 plus 15, that's about 45. So 45 and a half. But once again, because this one is this third function, so 1, 2, 3, this function right here, double an integer, because it's an int data type, we returned it as just a whole number, no decimal. Okay. For the fourth scenario, we have 3 parameters, 81, 110. So all of them are integers. So that gave us 191. Okay. And that was called by this function here, which has int, int, int. Okay. And lastly, we have a scenario where we take 2 doubles and lastly an integer. And it happens that our function is a double data type. So we are going to actually get a decimal value returned. So 192.1. Okay, and we can actually change the data types here. So we can say double for this one. Okay, so now instead of having 35 for the second one, we are now getting a decimal value return, 37 and 37.7, 35.7. Okay. So that's essentially the way you can use function overloading. So you can see how this might be helpful. Instead of having like sum only 2 integers, okay? Sum 2 integers, 2 numbers, 1 int, 1 double. So instead of having something like this, where you start passing them in your main, okay, as your function names for a different scenario, why would you have something like that when function overloading is available to you? I mean, this works, but function overloading makes it much more cleaner, much more simple. You can have the same function name, that perform different operations because it allows you to overload them. Okay, so this is a very beneficial way to make your code look nicer, simpler. It's just another method you can achieve those results.